One of my kids is learning how to graph polynomials, so let me do a video on how to graph that polynomial. I've already factored it. How to factor it, that's another story, but if you know how it factors, then we can graph it. The first thing we're going to do is to decide what happens when x is very large, so when x goes to infinity, and when x goes to minus infinity. A polynomial either will blow up to infinity as x goes large, or it will go to minus infinity. And similarly, on this end, if we go very negative, it will either blow to infinity or to minus infinity. So how do you decide? You decide based on the coefficient of the leading coefficient, the sign of the leading coefficient, and also the degree of the polynomial. The options are as follows. So if the leading coefficient is positive or negative and the degree is even or odd, this is what's going to happen at infinity. So when the leading coefficient, for example, here it's +1 and the degree is even, then it's going to look like this. It's going to go to plus infinity on both ends. If it is odd, if the degree is odd, such as in y equals x cubed, it's going to go to infinity at infinity and to minus infinity at minus infinity. And similarly, for negative leading coefficients, it goes to minus infinity in both ends. And if it's negative and odd degree, then it goes to plus infinity as you go left and to minus infinity as you go right. These four functions are very useful to remember. If you remember the graphs of these four, then you sort of remember all the possibilities for the behavior at infinity and minus infinity. And of course, you don't even have to remember the graph. You can just think about this function and think that when x goes to infinity, x squared will go to infinity, so it has to go that way. And when x goes to minus infinity, very large and very negative, the square will take care of the sign, and it also goes to infinity as x goes to minus infinity. Now, what is the leading coefficient of this polynomial? Is negative 2 times, and then the largest power of x that I'll get out of all of this will be x times x cubed times x squared, and that 2 times 2 plus 3 plus 1, that is 6. So the leading coefficient is minus 2x to the 6. So it's a negative leading coefficient, and the degree of the polynomial is 6, so it's even. So that means that it will go to minus infinity as x goes to minus infinity, and as x goes to infinity, it will also go to minus infinity. Next, we're going to look at the zeros of the polynomial in x. Now, since it's already factored, I know that the zeros, which correspond to the x-intercepts, are going to be at x equals 0, at x equals minus 1, and at x equals 2. So I've drawn those 3 points in here, and now what I want to know is what does the graph do around those 3 points? What happens at the zeros, at the x-intercepts? The possibilities around a 0 are these ones, and they depend on the multiplicity of the 0. So if you have a factor of x minus a to the m, so the 0 is at x equals a, and that power is called the multiplicity, and if that power is 1, even, or odd, then these are the possibilities. Now, if the multiplicity is exactly 1, the graph will be just a straight line through the 0, and we will tell which one it is from the context of what's happening with the graph. If the multiplicity is even, then it looks like an U or a downwards U, and we will see which one it is sort of from the context of the graph. And finally, if it is odd, then it looks like a saddle point like this. So let's see what happens in the graph we were talking about. We're now going to complete the graph one step at a time, starting from minus infinity and moving to the right. And at each point, what we need to know is what happens at the 0, at the next 0. So the first 0 here is at minus 1. So we want to know how to graph from here to here and a little bit farther. And that depends on what type of 0 I have. I have a 0 with an odd multiplicity, so it has to be a saddle point. Now, since I have to come from negative up to the 0, then it's going to look something like this, and then saddle point and go up. Now, I have to cross or touch the point x equals 0. How? The multiplicity is just 1, so I have to draw a straight line through 0, and then I'm coming from positive, so I'm going to go positive to negative. So it has to look something like this. Next, I need to know what happens from 0 to 2, but at 2, I have an even multiplicity, so I have to draw some sort of u, and since I'm already in the negatives, I have to draw some type of U like this downwards, and now I can connect from here, and then I have to go to minus infinity, so I just go down like that. So the graph is supposed to look sort of like that. Here, I've fixed it a little bit so you get a better sense of what the graph is supposed to look like. And this is the graph of the function on Desmos, and then you can see that we did get the rough shape of the graph right, except for the fact that between 0 and 2, it does drop quite a bit, much more than what we drew. We could have done a little bit better by plotting a number of points in between the zeros just to see what was happening in between. So for example, knowing the value at x equals 1 would have helped a lot to detect that drop. But otherwise, typically when a teacher asks you to sketch a graph, they're asking you to do what we did in this example.